So here we discussed about an IP addresses, mainly IPv4. We are talking. So IPv4 is okay 32-bit in size, whereas IPv6 is 128-bit. So in IPv4 there is a 4.3 billion IP addresses. IPv4 IP addresses are there from 0.0.0.0 to 255.255.255. So totally 4.3 billion. This is the exact number. Okay, it is represented in a decimal format, but you can see like this is the example of your IP address. How to read 192.168.10.23. So you can see there is a 4 parts are there. Okay, it's not one single line, it is 4 parts in the IP address, which is separated or divided by a dot. 4 means each part is 8 bits. So okay, 8 bits, that we call it as an octet. So we have 4 octets separated by dot. One octet size is 0 to 255. The maximum size of octet is 255. Okay, each octet is from 0 to 255 only. Okay. Yeah. This is the wrong one. So if any octet contains more than 255, that is a wrong IP address. Your IPv4 range is 0.0.0 to 255.255.255. The starting is 0.0.0 and it will start 1, 2, 3, 4, 5. Like it keep goes, and the last IP address is 255.255.255. Okay, so this total range of IP addresses are divided into 5 classes. Of course, there is a behind story why it is divided into 5 classes, but just now it's just like it. Okay, the class C is a reserved IP address. This range is completely reserved, research purpose, and used in some places. We don't know that. And class D is a multicast IP address. Okay, it is used by certain services and protocols for exchanging their informations. Okay, but to identify a device in the network, that is called an IP address. That IP address we are configured to devices. Which type of IP address? From class A, class B, class C, there are unicast IP addresses. Okay, and here the class A range is 0 to 127, class B is 128 to 191, class C 192 to 223, class D 224 to 239, class E 240 to 255. This is the total ranges, and we can recognize the which class of this particular IP address based on their first octet. So you have seen one IP address and how to recognize which class of it based on their first octet. Okay, in class A, if you check in certain websites kind of stuff, it will show 1 to 126. Because of this 0 series is reserved for a certain protocols like a DHCP, default routing concepts are there. It is used for a certain purposes. In entire 0 series is also we are not using. And 127.0.0.1 it is also reserved localhost loopback IP address. It is used for self-testing, same device access. For example, in my laptop, I have a Oracle database is installed. From where is the client? The client is also in my laptop only. So this is try to explain, guys. See, this is my system. I installed an application called Oracle DB. So it is my server. It contains a database. Okay, it contains a data. To access it from my system, I need a client application, right? SQL plus This is my client application. So I want to connect from client to this server application. Both are in a same system. Both are in a same system. Okay, this server and as well as a client application both are in the same. So I don't need a additional network connectivity here. I don't need any separate IP address or what we can say there is a switch, cables, NICs. This much we don't require. Okay, simple. I have a server here and I have a client here. How will I access? Using a localhost IP address. 127.0.0.1 is very simple. I can able to access. Just in case in my network, I have connected to a network. Okay, I have connected to a network. Okay. Something like this. Okay, naturally. This is a, for example, PC1. This is PC2. Okay, here I have a SQL client application, not server. I have a client application instead. Now I want to access this server, this particular server I want to access. So you cannot put a 127 here. If you put 127 means you are accessing same PC. So what it is? You have to give their IP address. For example, this machine IP address is 10.0.0.10. This PC IP address is 10.0.0.11. So what is the client at client? What IP address I have to give? Server PC IP address. Then only we can able to access. So that's the main difference, guys. To communicate to a machine, we use one machine to another machine. We use their IP addresses, right? We should have an IP address. Other system has an IP address. So we should communicate with the IP addresses, general IP addresses. But where we use this 127, it's a self-access, same system access kind of stuff. Okay, same device access. Next one is multicasting. What is a multicasting use? Use in different things like routing protocols, dynamic routing protocols use multicasting. Okay, certain protocols use multicasting. Certain services like WDS, BootP type of protocols use the multicasting. So multicasting IP addresses 127 series and the 0 series we cannot assign to our devices. Okay, so this is for recognizing which class of it. So check the first octet, check in the range, so you will understand which class of IP address it is. And also yesterday we discussed, guys, are you okay up to here?
Yes, sir.
Okay, then so what we discussed, so IP address is divided into network portion and host portion. Just like I showed certain roll numbers to understand which network you are belongs to, same network people will communicate. See, this is the 17th batch. This is 18th batch. Think like this. So very simple example, only two parts example only. One is batch number, another one is a roll number wise. Is belongs to different batch, is not belongs to our batch. Okay, similarly like this. So in our IP address is also there is a network portion and host portions. Devices are in the same network means there are communicate each other. Devices are in the same network can communicate each other. Means their network portion is same and their network ID is also same. Network portion is same or a network ID is same. Network portion must be same and host portion is different. Okay. So this is for class A, class B, class C. These ranges only we are using. Okay. So this is network, and host portions. Class A first portion is network and remaining are a host portions. Class B is first two portions are network portions, remaining portions are host portions. Class C, first three portions are network portions, the last portion is host portions. Okay, there is a default subnet mask which represents this network and host, and it will divide your network portion and host portions separately. It tells what is your network ID. To communicate in the network, so two devices want to communicate in the network, their network portion must be same, host portion can be different. Okay, so host portion can be different. One difference is enough. Okay, of course there is a few points also there, that is to avoid this part of confusion, but I will try to give example also. PC1 and PC2 are communicate each other. Why? Because of their network portion is same, and they are unable to communicate with the PC3 and PC4 because of, you can see there is a network portion in the first portion is different. Here second portion is different. Okay, as compared to this is 134, 127, this is 89, this is 88. So they cannot able to communicate with the PC3 and PC4. Same system divide IP address into network portion and host portion using subnet mask. This subnet mask uses AND gate operations. So logical gate operation, AND gate operations. Okay, to divide it, and it will tell us what is your network ID. And always remember, if two systems are want to communicate each other, their IP address, they must have an IP address, and the IP address must be in the same network. Means their network portion must be same, or a network ID must be same. So those things we discuss till on Saturday, mainly in a network IP addresses. 2 points mainly related to IP address. I want to tell about private IP first, but we are in the last part is subnet mask. Okay, guys, this subnet mask okay, so can be represent in slash notation. Slash notation. This slash notation, like a slash, it is nothing but also called as prefix. Prefix. Okay, this n represent the small n, small n. Slash n. The n means number of ones, means that is called a network bits in subnet mask. If you write 255.0.0.0 in the binary format, you can see how many number of ones are there. 1, 2, 3. This is the 4. How many ones are there? 255 means 8 ones. 255 means 8 ones. Okay, 8 binary bit. How many ones are there, guys?
8.
8. Similarly, we go to 255, 255.0.0. 1, 255 means 8. Now 2 are there.
16.
Very good. Now
24.
20. Very good. But this subnet mask may different from other subnet mask. Sometimes we can use not default one. Okay, depends upon your network or a subnetting concept. So then 255, 255, 8 plus 8, 16. What about a 240? What about a 240? 240 is 4 ones, 4 zeros, because I know it. Okay. So if you convert 240 into binary, it is 4 ones, 4 zeros. Means 8, 8, 16 plus 4, now this become 20. Okay. So we can write an IP address like this. Think like this: 192.168.1.12, and their subnet mask. Okay, IP address subnet mask, or you can write same IP plus 24 also. Both are same. Either you write IP address and the subnet mask. Here also I written IP address and subnet mask in the form of prefix. Okay, the form of prefix. It's CIDR method. CIDR method, classless inter-domain routing. Okay, it is a slash notations. It is a slash notations. Okay, so it is a prefix. It's the word they are used sometimes prefix. So slash 16, slash 20, slash 32, slash 40, 14. Sorry, not 32. Okay, okay, whatever it is, it's a slash 22, slash 25. Okay. So what is slash 25? What is slash 25? 25 ones. Now 24 ones completed. 25 ones. Somewhere you see an IP address with a slash 25. This is the binary number. What how to write? 255, 255, 255. First three is 255. 8 ones means 255. Okay. 255, 255. What about this? 128. Okay. For starters, you can use a conversion, but learn the converting binary to decimal format. Sorry, binary to decimal, decimal to binary, binary to hexa. Guys, understand this example? What is mean by slash 25 means? What is mean by these two slash? So you can represent, you can write an IP address, or you can represent an IP address.
Hello, good morning. This is Prem calling from.
Tell me. Yes, yes. No, I don't require it. I don't require it. ఈ టైం ఇంగ్లీష్ అది క్రెడిట్ కార్డ్ ఉంది, క్రెడిట్ కార్డ్ మీద లోన్ ఇస్తుంది. Loan. Sorry guys. Okay, so I hope you got the point of this. Okay, why it is this? Why different subnet mask is came into market? Okay, so the concept is subnetting. I don't tell anything about a subnetting. Okay, just I am giving only one line. Okay, subnetting is a concept is you are dividing a network, a logical network, dividing a logical network into multiple subnets, small networks. Okay, number of networks, subnets increases. Number of subnets increases, the number of hosts means number of devices, number of IP address hosts per subnet increases. Number of subnets decreases. Okay, to divide a network means a logical network into multiple networks, subnetworks. We need to change subnet mask. If you change the subnet mask, automatically the network and host portion changes, so your network also changes. Only one line, as I said. Okay, I don't go to an examples here. It's otherwise it is too much for me. Not too much, but I don't want to spend more time on it. And there is a few additional concepts also there. Okay. Whether we should go or not, I'm thinking. I'm going. Anyway, so the concept is it's a range is 0 to 127, but you have to change to 1 to 126 also good. Okay, because 1 to 126. Okay. We have to keep like that. Okay, this is the class C, class B, class C guys. I'm going to take a class C example. And already we know that this is the network host portion it is. Class B, network host portion. Class A, network host. Small count, we will do it here guys. I'm taking one class C IP address. First of all, I'm taking one class C IP address 192.168.1.0. This is the one network, starting of network it is, because of this is entirely network portion. So this should not be changed. This should not be changed in the entire network. The start with a 0. You know, this one called a network ID. Network ID, which we cannot assign to any device. We can't assign to any device means any NIC. We can't configure this one. You have to configure from here 192.168.1.1. This is the first valid host IP address. What is first valid IP address? We can assign to any device. You can assign to any device. This is the first one. Then what is the next one? Okay. So this is also we can assign to someone. This also we can able to assign to someone. Like we can assign 192.168.1.254. Up to here we can assign. And in this sequence it is a last valid host IP address. Up to here we can assign. Up to here we can assign. The next one is, this is called a broadcast. This is also we cannot assign. Their purpose is different. Can't assign to any device. So this is we can. What is the next one? Anyone? Please tell me. Anyone? What is the next IP address possible? Guess it, anything guys, no problem, right or wrong, no problem. 1.255. What is the next after 1.255? 255 become? After 99, what is the next number? Hmm?
1.
Mm, 20. Next network.
The network I think
255 is last.
yeah,
No
255.
idea, sir. Is the last.
Yeah, after this one, what number it will come? Ask simple. After 99, what is the next number?
100.
100, sir.
Same. This is the last. Once it is completed, 0, 1. Increment always.
Okay.
1, 2.255. What is the next number?
Okay. 3.255.
3.0.
3.0. Okay, sir. Yes, sir.
And 3.1, 3.2, 3.3. Again, it will goes to the last.
Okay.
It's a simple numbers, guys. It's not a new technology. It is IP addresses are simple to understand. It is nothing but a numbers. 1, 2, 3, 4 numbers only. Okay. So this is a different from above. It's a different from this, right? Here it is. I have 1. This is a 2, and this is class C. First 3 portions are network portions. First 3 portions are network portion. Both are different networks. This is one network. Okay, and this is a different network. Okay, so that's the point here. So in one single network, you can take one single network. So you take a one single network. These are the IP addresses 0 to 255. 0 to 255. Totally 256 you are getting. Out of that one, this is we cannot assign. This is we cannot assign to any device. We can assign from 1 to 254. 1 to 254 only. Okay. So here, this is the host part. This is the host part. Okay. This is the host part. So you can see here it is 2 to the power of 8. How many number of host bits? 8 host bits. 1H means this is host part. Host represents 0 bits. Okay, this is number of host per network. Okay, and -2 means why -2? We do not assign this network ID and broadcast ID. We have to assign from these to this. The first one and last one we can't use it. Okay, so it is 254. Same, it is go for a like this. Number of hosts are 2 means so 2 to the power of 2H means 8 plus 8 16 minus 2 2 to the power of 16 minus 2 65,534 IP addresses. You want you can calculate now, Paula. Okay, better take one calculator and take it. 2 to the power of 24 means how many H's are there? 3H. 3 host functions. 3 octets. Each octet 8. 8 plus 8 plus 8, 24.
24.
Yeah. We should use equal here. It is even I forget. So 16 777 214. Okay. So very simple. It go to calci. 2 to the power of 8, 256 minus 2, 254. Next 2 to the power of 16 minus 2, 65,534. 2 to the power of 24. What is 16 777 216 minus 2 is 16 777 214. Okay. So can you see if you take one class C IP address, how many hosts you are getting, how many IP addresses you are getting to assign to the number of hosts. Here I am taking one example, guys, try to understand. Okay, I have a 20 devices are there. Which class of IPs you will prefer? Class A or class B or class C? I have 20 devices only. Which class of IP address you prefer? Number of devices, number of hosts, network. One network, one single class C network, we are getting 254. How many IP addresses we are getting? 254. Which class we are prefer? I prefer class C. Maximum 254. If I take class B, I am getting 65,000. It is better than class B. Class C is okay. if I have a 50 devices, which class?
Class C.
Class C, because we are getting
250.
254. I have a 200 devices. Still
Class C.
class C only.
Plus 6.
I have 300 devices.
Then you'll go for
Class
class B.
B.
Very good. Because class
It
C
is
only
it exceeds
254.
254.
Now I have more than 254 means I have to go to class B. But if you observe, class B is giving 65,534. How many are wasting we are?
68,234.
65,234. Very good. That many IP addresses we are not using.
Using.
Okay. So like that, if you take 5,000 class B,
Class B.
class B is good. Okay. 66,000.
Then I have to go to class A.
Class A.
Then you have to compulsory go to class B. But how many are wasting? So many are we are wasting.
Too many.
Right? Almost 16 million 711 kind of 711,000 IP addresses we are wasting. Okay, guys. So it is based on number of devices you have to prefer which class of IP addresses, but sometimes you are getting more number of devices. So we are getting 254 minus 2 means minus 20 means 234 only we are not using here. Okay. So this is best utilized. 200 devices, good. But 20 devices, so number of waste of IP addresses. Okay. Public IP addresses are paid IP addresses. You have to pay for using an IP address. Okay. Okay. And number of IPv4 addresses are limited, and number of IP addresses, IPv4 addresses are available is limited. Okay. To best utilizing util so initial one is correct. Okay. Best utilize of this public IP addresses. Public IP addresses or IP addresses. We use one technique called subnetting. We use subnetting concept. Second one is private IP addresses. Use using local or private networks. Okay, so these private IP addresses are only for local or private networks only. So it is not required. These certain ranges, any person, any local network can configure IP addresses any IP address network. Any local network can configure any IP address network in private range. Okay, lines are difficult to type now. Okay, so they're given a private IP addresses like this: class A, class B, class. There is a few techniques are there, so one by one I will tell. This is 10.0.0. Exactly say the entire 10 series. The entire 10 series is private network. You can use it, I can use it, anyone can use it. In this world, the millions of people are using 10 series. Okay, this 10 network, they can use it. No problem. Okay, so you don't need to buy. No need to pay for private IP address. Private IP address are addresses are non-routable in public network. Means internet. Okay, you cannot access with private IP. Can't access in public with private IP. Not that part I will tell again once again. Okay. In class B, 16.0.0 to 172.31.255.255. Okay. This is 192.168.0.0. You may observe so many times the network it is showing so many people for your network or your friend network. Okay, anyone networks. First, these two are there, right? Guys, this is will give you almost 256 networks. This is a only single network, one network only, because it's a class A, network portion is 10, that it is also network portion is 10. This is class B, this is a network portion. Okay, 16 to 31, 16 to 31, 16 to 31, it is around 16 networks we are getting. Okay, 16 network IDs. 16 network IDs we are getting from class B. 256 networks we are getting from class C. Only one network from class A. Okay. So in the world, any person without paying any amount, they can use these networks in their local network, in their private network. Okay. It is, we cannot access public network with private IP. Public network means the internet. Private IP. You have a private IP address into your desktop, so or laptop. You can't access public IP directly. We are not accessing directly, so we are accessing indirectly. Use NAT and PAT technique. Access network. Guys, for your understanding, so I'm using this small explanation. Try to be understand. As I said, to communicate in network, what we require? Connectivity, right? First is important, connectivity. What is the next one? IP address, then protocols. So this is my APC, A, B, C. This is something like think like it is a server. I have a server A. Example, it is some kind of web server or a database server it is. Okay. So I want to access from B to server. So we need an IP address. For example, I'm assigning IP address also. Simple matter, I will put a simple IP address. Okay. Easy way, 10.0.0. This is a 12. Okay. This is 10.0.0.11. 10.0.0.13. And 0.0. Maybe a 14. Okay. So these are the IP addresses. So here, if A want to communicate to B, how it will communicate? So with a private IP address 10.0.2. It's enough. We don't require any internet. A to B communication. A to B communication. So we don't require any internet kind of concept. We don't require any public IP. So you don't need to pay for a IP address. You can use any private IP address. Okay. Intranet. So B to A to B, or C to B, like this. B want to communicate, open the web server. So I don't require any public IP address, private, okay, public IP address, routers, modems, internet connectivity, not required. Guys, understand? You have a server. You have a server. Someone in the internet want to access your server, but you are in a private network, so they cannot able to access your server, right? Just again, how to connect it to our server, how we are able to connect it to internet. This is the diagram, right? Do you remember first class? Guys, you have to read every day, go through things, okay? It's not like an academic, okay? This is my router, modem, ISP. Okay. So I am connected to internet. From this user, this is sometime user is there, outside person is a user, want to access your server. How you can able to access your server? With your private IP, right? What is the IP address? They can access, right? It is 10.0.0.11 or 14. He type like this. Packet goes nothing. It cannot go to your public because it's a private IP. Automatically at your place only it will be rejected. Okay. or at least at ISP it will be rejected. He has to connect it to ISP, right? So his request is not go for a public. It will be rejected automatically. So that is called a non-routable in a public. Non-routable in a public. Okay, this is my IP. This is server IP. You want to access from internet. He send a request. He's also connected to some ISP kind of stuff, routers, switches kind of stuff. So it won't cross from this ISP. Automatically, it got rejected. Okay, is also connected to internet. So then how we can make this person to access? How can we make this person to access this server? We have to assign a public IP address. Other than private IP addresses, other than reserved IP addresses, all remaining IP addresses we can assign. We can assign a public IP. And you have to tell this public IP to ISP. So then this guy will send a packet, for example, 11.0.0.14. Now it is a public IP address. 4. Now it is a public IP address. Okay. So what he will do? He will try to access my PC, my server with this IP address. So the request go to internet to this ISP. They will reach to my server. So this is public IP and private IP. Your private cannot be accessible through internet directly. So you must have a public IP address to get access through internet. To get access through internet. Yeah, get access through internet. Guys, understand what is use of private and public?
Yes.
Very good. Very good. But not always. So this is in a private area. My server is in private area. This is my private network. This is my private network. My LAN network it is. Okay. So I want to use private IP, not direct public IP address. So what I will have to do it. Next one. To communicate not only from outside, to communicate from inside to outside means either you will communicate from your PC to internet. Okay. Either you want to communicate to outside network like google.com, facebook.com, youtube.com, or you want to communicate from their network. Okay, you want to get communicated from outside to inside, you need a public IP address. So but we are in a private, we have a private IP address, and directly public IP address is not suggestible. So in private I will maintain intranet. In private I will maintain intranet. In public, so I will use public IP address. So what I have to do, I have to use a technique called a NAT and PAT technique. In generally, our all broadband connections use NAT technique. So what is NAT? This is network address translation. Okay, at that part theory I will do it. So this is how NAT translations will happen. Right here. In this router itself, we don't do it. So generally it happens directly. So have a PC called a PCA. This is my private IP. So I have to buy one public IP address. So then my A PC can communicate inside to outside. For example, I'm taking some IP address like maybe a simple address I will take. Okay, easy, right? 1.1.11. So which we India we don't use that one, but just for our address. I have BPC. BPC want to communicate outside of the network and outside to inside. I want to communicate. It is not required class A kind of stuff also. Anything which is not private. So I purchase one more. This is our server, right? So I purchase just like 4 or 5 or 10 public IP addresses. I map private IP address to public. So not private inside IP addresses to some public IP addresses. Okay. What I've done, I map my LAN IP address, the local or a private IP address to public IP address. Outside IP address. There is a lot of wording is there. So in internet wise, I am telling. Yeah, okay. So inside, outside, local array, my private IP address to public IP. So each device has their dedicated IP addresses. It's a one-to-one type. Okay, one private, one public. 4 private are there, 4 public is required. Now this guy, this person, or maybe someone in the internet want to access my server, he will send a request to ISP. Up to ISP it will reach. What is my server? 1.1.14. Request is sent to ISP. ISP to here it will happens, and then it will translate to 10.0.0.14. Okay. Again it retranslate from here to here where it is map is there. It reaches means public person access me with the public IP address, and it is translate into 10.0.0.14. So packet reaches to me. Packet reaches to me. Guys, this is called a NAT technique. Same goes. A want to send a packet outside. How it will send up to here, up to this private IP. Once it is crossed, it send outside. It will go outside with this IP address. Same goes for a BPC, CPC. When it is sending a packet outside, internally it's 10.0.0.12, but when it is crosses our router, then it use a public IP address. So when it is communicating outside of a network, public IP. Okay, request send with this IP address only. So this is NAT technique. One more is there, that is called a PAT technique. Guys, understand NAT? What is NAT? Network Address Translation. Network address translated. Maps inside local IP address to outside IP address. That is little hard for you. So when you hear this is a original word, but I am changing it. Okay. So it maps your private IP address means your local private IP address to a public maps a private IP addresses to a public IP address. So user in private IP in private network can communicate outside means public network. Public network means internet. And also servers in private network get access by to internet. Okay, these are the some points. Users in the private network can communicate outside network or a public network or internet network it is, so they can able to communicate. Outside network. Okay, so servers in the private network get accessed by or get access through internet because inside private IP, outside public IP, NAT technique using network. So here it is how NAT translations are there, guys. I have an IP address, same technique, same I'm writing here. These are my private IP addresses. Taking more time, no problem. So this is my private IP. It's not required to follow same 1.11 or kind of stuff. You can follow something, depends upon your things. Okay, so it's not mandatory. Yeah. Otherwise, it's not always. So each IP address, each private IP address mapped to one of a public IP address. Okay, a private IP. So exactly NAT, a private IP address to 1-to-1. Sir, 1-to-1 type. 1-to-1. One private, one public. One private, one public. One private, one public. So 1-to-1 type. Next. But what is the problem with this NAT technique? What is the problem with one NAT technique? More number of devices, more number of devices, so more number of private IP addresses. So we need more number of public IP addresses. Okay. So more public IP address. So how many public IP address use? 4. But how many servers I have? Only one server. So for A, B, C, I don't require public IP address. Okay, I need a public IP, but each one having one public IP means it is cost more. Think like this in your home or in my home. Think like this in my home. I have a laptop and there is a mobile phone and a tab. So I need a minimum 3 IP addresses. And my sister's laptop and there is a 2 mobile phones. Okay, and a TV is there and a TV need another IP address. Okay, like devices, like we have another laptop, mobile phone. Like this, people are having now at least 10 IP addresses required per home. So we can't buy a 10 public IP addresses, right? We cannot buy a 10 public IP addresses. Very difficult to each IP address is very costly, and number of IP addresses become wasted. Already we told that point, right? So one is subnetting concept. Even the subnetting concept also, we cannot. We are wasting a lot of IP addresses because number of devices are very high nowadays. So what we are using, PAT technique. PAT technique. So you know how PAT technique it is. It's a port address translation. Port address translation, also called as NAT overload. Port address translation, also called as NAT overload. So here it is. You have a devices. For example, in my network, general network will take it in my home network. 168, 1.11 system is there. 192.168.1.12 system is there. 192.168.1.13 system is there. 192.8.1.14 system is also there. And of course, without public, you cannot access public network. You don't need to get access. Think, NAT is compulsory when you want to get access from outside to inside. Okay, but we are not required to. Your laptop is no need to access it by outside to inside. You have to access from your to outside, right? So what we are using, port address translation. What I'm using, I have a one public IP address, some public IP address. I got it now. All are using same public IP address, but it will understand by some port mapping. Port mapping. So just for example, I'm giving this port mapping. Okay. IP address, public IP address is same. If you observe, the public IP address will be same always, but the private IP address is different. Means different devices having different IP addresses, but all are communicating with the same public IP address. How our system will recognize? So who is requested and what service it is? So how they will understand? It will understand by this port mapping only. This port mapping. So it is. So this is belongs to this device. Okay. So they'll automatically maps these kind of stuff. So it is a one-to-one type, not one-to-one, many to one type. Means, for example, 10 private, 1 public, or 2 public, depends upon your ISP. Okay, depends upon your ISP, they will configure. For home networks, for home, small office, home office networks, Okay, ISP will take care of public IP and your PAT. Okay, your PAT, port address translation. Guys, understand what is private IP address and their ranges? What is the use of where we use private IP addresses? What is NAT? What is PAT? Okay, no one is speaking. At least read the names, so later we'll understand. Many questions?
No, sir.
No, sir.
So, very simple, guys. Okay. Instead of writing there, I am writing here. I put here. Okay. Just try to understand how we are communicating. Okay. So take a break. 12:15. Okay. I don't take more time. I'm here only. 12:15.